In this lesson, we are going to learn how we can measure the circle. We have already learnt that the closed shapes have rectangle and square having area and perimeter. Pasting of tiles on the wall, paving a parking lot with stone, fencing a field, or some of the places where the knowledge of area and perimeter of rectangle are essential. In this chapter, we have extended this concept to circles. The invention of wheel is perhaps the greatest achievement of mankind. Can you tell me what is the name of the picture? Yes, it is a wheel of bicycle and car. Will you name the shape of both the figures? Yes, it is in circular shape. Will you tell me the distance covered by the wheel when it rotates once? Place the wheel on the floor in such a way that the marked point coincides with the floor. Take it as the initial point. Rotate the wheel once on the floor along a straight line till the marked point again touches the floor. That is circumference.
For polygons, perimeter is the sum of the lengths of their sides. Circles have perimeter too, but we give it a special word, circumference. The circumference of a circle is the distance around the circle. Let's take a look at the ratio of the circumference to diameter in a couple examples. Here is circle 1 with a diameter of 1 meter and circle 2 with a diameter of 2 meters. The distance all the way around circle 1, the circumference of the circle, is 3.1415926 meters. The circumference of circle 2 is 6.2831852 meters. To form the ratio of the circumference to diameter, we divided the circumference by the diameter. For circle 1, we have 3.1415926 divided by 1, which equals 3.1415926. For circle 2, we have 6.2831852 divided by 2, which equals 3.1415926. Did you notice anything? The ratio of the circumference C to diameter D of both circles simplify to the same value, 3.1415926. C divided by D equals 3.1415926. The ratio of the circumference of any circle to its diameter is always the same value, 3.1415926, named using the Greek letter pi, which looks like this. This is the formula for pi. Now we can use the pi symbol instead of that long number and show a formula of the circumference and diameter. When we multiply both sides of the formula by d, we get C equals pi times d. Now we can find the circumference C of any circle as long as we know the diameter d. If you have the radius, you can still find the circumference of a circle, since radius is equal to half the diameter. We simply change the formula to C equals 2 pi times r. Let's try a practice problem and find the circumference of a circle that has a diameter of 20. Let's start with our formula. Then plug in 20 for our diameter. You did it. We can leave our answer in terms of pi, so the circumference of the circle is 20 pi units. Now we know about radius, diameter, and circumference, but there are more parts to a circle left to cover. Imagine you sit down to a delicious hot pizza, but it's not cut. Let's say you cut away a single slice like this. The portion of the crust in the cut pizza is much smaller than the rest of the crust. The smaller portion is the minor arc of the circle. The larger part, the remaining circumference, is the major arc. A minor arc is a portion of the circumference where the central angle measures less than 180 degrees. A major arc is a portion of the circumference where the central angle is greater than 180 degrees. There is more to the minor and major arc, but we will cover that in the next lesson.